in GCSE rate to reaction topic, you'll be asked to explain factors affecting reaction rate and how they affect reaction rate. And you need to be able to do that using collision theory. One of the factors that affect reaction rate is concentration, so you need to be able to explain what concentration is and use the right words. Students often lose marks in questions about concentration because they talk about the number of particles, and that's not quite the right vocabulary to use. So I'm going to try to explain the words that you need to use to get the marks in the question on reaction rate and concentration. So you need to mention particles. We've been studying since year 7 that all substances are made of particles. So this is a glass of water. The water is made of water molecules. We can't see them because they're too small. But in here, if we could see particles, we would see millions and millions of water molecules tightly packed together. Not in fixed positions, able to move out of position, able to roll past each other, but tightly packed, given water its fluid movement. Okay. If we have a look at a bottle of squash, so a diluting juice, what's in here is mostly water. You can look on the ingredients label. The first listed ingredient is the most abundant ingredient, and it says water. Okay, so if you could make yourself teeny tiny particle sized person and dive in here and swim around, most of what you would bump into would be water molecules. Okay, but obviously if we have a look at this, it doesn't look like it's just water molecules. Most of it is water molecules, but there's something in here obviously that's given it its purple colour. For easiness, we're just going to refer to them as purple pigment particles. Okay, so in the jug, this is a mixture. It's a mixture or a solution which is mostly water molecules. If you were to make yourself teeny tiny particle size and dive in here and swim around, you are going to bump into mostly water molecules, but every now and then you're going to bump into a purple pigment particle as well. Okay, so all the particles are moving around in here in a mixture. So I spoke to you about important vocabulary, important words to use in questions like this so that you can score the right number of marks. So the first word we want to talk about is volume. Okay, now if we were in the science lab, I would measure using a measuring cylinder, but because I'm at home, I don't have one. The measuring jug doesn't have very good resolution on the scale, so I'm going to use a syringe instead. So it's a 20ml syringe, and I'm going to put in 5 syringefuls of the juice mixture into the first glass. Okay, so 100. Okay. Into the second glass, I'm going to put just 1 syringe. So hopefully you can see, looking at the 2 glasses, that obviously something is different between them. The difference between them is the volume, okay? The amount of the mixture that's there. This is a greater volume and this is a lesser volume. You can hopefully see that the intensity of the colour is equal. Despite the fact that the volume is different, the intensity of colour is equal. It's easier to see that if we draw up an equal volume in another syringe. If we take equal volume samples here and set them onto the white paper, if we look closely at these syringes, we can see the intensity of colour is exactly the same, and that's because in an equal volume, the number of purple pigment particles that are spread through the water is the same in each syringe. Despite the fact that the volumes were different here, the concentration of the purple pigment particles is equal. Equal concentrations, but unequal volumes. So what we're going to do next is I'm going to equal the volume up. So I'm going to add this 20 mils of mixture. Again, remember this mixture is mainly water. I'm going to add some more water. There's a key vocabulary that goes along with that, which is to dilute. So I've got 1 syringe of the juice mixture in there. I'm going to add 4 syringes of the water, and that's going to bring the total volumes in each glass to 100 mils. Okay, so then the volumes will be equal, but hopefully you'll be able to see that the concentrations then are very different. Okay, so now we have equal volumes in each glass, 100 mils in each glass, but we can see that the intensity of colour is much greater in this one and much lesser in the one that was diluted by the addition of water. So now we think about being tiny particle sized and jumping into these glasses and having a swim around. Again, in both mixtures, you're mostly going to bump into water molecules. But in this one that hasn't been diluted, you're more likely to bump into a purple pigment particle. How much more likely?
The first glass had 100 mils of juice mixture taken straight from the bottle. The second glass had just 20 mils of juice mixture taken from the bottle, which was then diluted to a total volume of 100 mils with extra water, and then mixed to spread the particles evenly through the water. So glass 1 has 100 mils of bottled juice in a total volumes of 100 mils, whereas glass 2 has just 20 mils of bottled juice in the total volume of 100 mils. So the concentration of the mixture in glass 1 is 5 times greater than the concentration of the mixture in glass 2, which means that in glass 1 we have 5 times as many pigment particles spread through the water molecules than we have in glass 2.
How does that tie into reaction rate? Reaction rate is about collisions. In a reaction, in a chemical reaction, you have to have the two reactants come together in order to react. Okay? And that's called a collision. If there is a greater concentration of particles, they are going to collide more frequently. There's more purple pigment particles per unit volume in the undiluted glass. So there is going to be more frequent collisions between those particles in the undiluted glass. Okay? As we dilute, we reduce the concentration. We reduce the number of particles per unit volume. Okay? So these are the important key terms that you need to use. In a reaction, and for example, a common reaction you'll get in exam type questions is the reaction between a solid substance and acid. If you dilute the acid, there are less acid reactant particles per unit volume in the diluted acid. If there is less acid reactant particles per unit volume, then there are less frequent collisions and therefore the reaction rate is lower. Higher concentration, more particles per unit volume, more frequent collisions, therefore more successful collisions and a higher reaction rate.